constant. Now let's move on to common emitter connection. In common emitter connection, uh, this is the most important one in all the three types of connections: emitter, collector, and base. Common base, common emitter, and common collector. You can see that npm transistor, when used, this is the form of common emitter, and when pnp is used, this is the common emitter form. And then let's move on to the formulas. IE is equal to IC plus IB, which is of the form beta IB plus ICEO, leakage current in collector and emitter part, plus IB, where beta is equal to IC by IB, IC by IB, and you can see when formulated at last, IE is equal to beta. ICEO is equal to 1 by 1 minus alpha. ICBO is equal to beta plus 1 ICBO. You can see that when base is open, there is no current passing on. ICEO is the one which passes, and when that is the leakage current. So when IB is equal to 0, base is open, the collector current will be the current to the emitter. This can be written as the ICEO, indicate collector emitter current with base open. This is due to minority carriers, the leakage current is. So this is the characteristic graphs for characteristics of common emitter connection. You can see between the graph between the base current to voltage of base emitter voltage. As VCE increases, here the ratio decreases. In common base connection, we have seen that generally the as the slope, I mean the constant value increases, the slope increases, but here the slope is decreasing and the ratio is decreasing. So that is the input characteristics. Base emitter section is forward biased here, and compared to CB arrangement, IB is less rapidly with VBE. Therefore, input resistance of CE is higher than CB. And output characteristics, you can see that as IB increases, the constant IB increases, the ratio between IC and VC, collector current and collector emitter voltage increases. So the common collector connection, this is less important than the other two connections. So IE is equal to IB by 1 minus alpha plus ICBO by 1 minus alpha, and these are the formulas. Gamma is equal to 1 by 1 minus alpha, and beta is equal to alpha by 1 minus alpha. So this is the table actually, which can come in forms of objectives. Input resistance is low, about 100 ohms for common base, low for common emitter 750, but very high for common collector case, where it is 750 kilo ohms. And output resistance is very high in case of common base of 450 kilo ohms, and high for common emitter 45 kilo ohms, and low for 50. You can see a pattern of here it is increasing and here it is decreasing, and about 150 voltage gain is nearly 150 for common base, 500 for common emitter, and less than 1 for common collector. That's why it is very less used, but it too has its own purposes. Applications: for high frequency applications, we use common base. For common emitter, we use for audio frequency applications, and for impedance matching. Current gain is no less than 1, and common emitter current gain is high beta, and common collector is appreciated. Thank you.